In this video, we will go over another matrix multiplication. Over here, we are going to choose two matrices, two square matrices. Both of them are square because the number of rows and columns are equal in both these matrices. So it's a 3 by 3 matrix multiplied by another 3 by 3 matrix, where each of these numbers corresponds to the number of rows and columns of the first matrix, and then rows and columns for the second matrix. The rule for matrix multiplication is, as we have noted before, the number of columns in the first matrix should match the number of rows in the second one, which over here it does. And the resulting matrix after matrix multiplication will have the size of 3 rows and 3 columns, so the outer dimensions. All right, let's set up this problem as usual in the general case first. We have got two matrices A and B. I've chosen elements of A with a subscript denoting the location of the element. So for example, A13 means it's the first row, third column element in A. A32 means it's the third row, second column element in A. And you could apply this to all 9 elements in A and also to the all 9 elements in B. Let's first write the size of A. So 3 rows and 3 columns, so it's a 3 by 3, and 3 rows and 3 columns for matrix B as well. It's another 3 by 3. Now how do we actually perform this matrix multiplication to get our A multiplied by B matrix? So to get the first row, first column element, we are going to take the first row of A and the first column of B and perform a dot product, which means we are going to evaluate A11, B11 plus A12, B21 plus A13, B31. So all of that is being written up as our summation right here. That's one element, the first row, first column element. Next, if I wanted to find out the first row, second column element, then I would just simply move the column to the second column in B and then perform the dot product again. So now I've got A11 multiplied by B12 plus A12, B22 plus A13, B32, giving me the second element, or specifically the first row, second column element in the resulting matrix A multiplied by B. And similarly, I'm going to move this all the way down. That would give me another dot product, another series of terms that I need to add up, and that would complete the first row. Now, if I want to move this to the second row evaluation, then I'm simply going to move this down and then move this one all the way up over here, another dot product. So once I do that, I will be evaluating the second row, first column element in the resulting matrix. I'm going to do that similarly to evaluate all the other remaining elements, all 9 of them. So if we do this right, our result is going to have 3 rows and 3 columns. Those are simply the outer dimensions of A and B. So 3 rows and 3 columns. Let's just highlight those rows and columns. Let's see. I'm highlighting the rows in green. One column, 1 row, 2 and 3 rows, and then my columns are 1, 2 and 3 columns. All right, let's apply this to a numerical example. So I've got A and B, two square matrices of size 3 rows and 3 columns for A, 3 rows and 3 columns for B, with numbers, so this should go faster. I'm trying to evaluate A multiplied by matrix B. In order to get my first row, first column element, I'm going to take the first row here and the first column in B, and then I'm going to do a dot product. So I'm going to get 1 multiplied by 1 plus -1 multiplied by -1 plus 0 times 2. Similarly, to get my first row second column element, I'm going to move the column to B to the second column. Then I'm going to evaluate the dot product again. So I've got 1 times 4 plus -1 times 0 plus 0 times -3. Similarly, my next element can be evaluated as 1 times -1, -1 times 2, 0 times 0. And then we'll write all the other, to move down to the second row, need to move this down to the second row and bring this all the way up. That is going to give me the second row first column. 2 times 1, 1 times -1, -2 times 2. Then the second column. 2 times 4, 1 times 0, -2 times -3, and then last one, let me write this quickly. I've got -2 here, and then I need to add 2 to it, and then the last one is of course 0. Alright, let's move this down now to get my last row in the product. So I've got, and I need to bring this up over here as well to get my first column element. So 0 plus 2 plus 0, then moving it up 1, I get 0 plus 0 plus 0, so that's a 0 there. And then for the last one, I've got 0 plus -2 times 2, so that's -2 all the way. So I'm trying to do this very quickly. Alright, so let's try to write the result here. So for the first row, first column, I've got 1 plus 1 plus 0, so that's 2. Then I've got 4. And then I've got -1, -2, so that's -3 there. 2 minus 1 is 1. 1 minus 4, -3. Then I've got 8 plus 6, 14. Then that simply is 0. That is 2, 0, -2. Alright, so I think we are ready to write the result here. So 2, 4, -3, -3, 14, 0, 2, 0, -2, and it's a 3x3 matrix. Alright, I hope this example helps.